Bio. We are starting chapter 4 today, and the title of this chapter is Communities and Ecosystems. So these are two words that we learned in our last chapter, and so now we have a whole chapter just focused on these, and this is going to be kind of a focus on the different parts of the world, different animals that live in different temperatures, different climates. So we're going to focus on how different communities and ecosystems interact with each other and how individual ones are made up. So our first section in this chapter is going to be titled The Role of Climate. So we're going to look at how does climate play a role in terms of communities and ecosystems. So the first question we need to answer is, what in the heck is climate? So first off, two words that you might get used interchangeably, but they're not the same thing at all, is weather and climate. So weather is the day-to-day condition of Earth's atmosphere at a particular time and place. So the weather today was rainy. So now that's different from climate, because climate refers to the average year-after-year conditions of temperature and precipitation in a particular region. So climate, it looks at more of the long term, where weather is just the day-to-day thing. So just because it rained yesterday does not mean that it rains every single day, so our climate would not be considered rainy. We'd have to look at, how much precipitation do we get, and then we can just get an average there. So know the difference between weather and climate. That will pop up at some point in time. And climate can be caused by various things. Trapping of the heat by the atmosphere can be caused by latitude, so where it lies on the Earth, the transport of heat by winds and ocean currents, the amount of precipitation, and shape and elevation of land masses. So all those different things can affect the year-to-year average of basically the conditions of the atmosphere and temperature and things like that. So those are all things that that climate can be affected by. And so one big thing that affects the climate is something known as the greenhouse effect, and so we're going to look at how it helps us maintain the biosphere's temperature range. So just some background information on the greenhouse effect. It's going to say that atmospheric gases that trap the heat energy of sunlight and maintains Earth's temperature range include carbon dioxide, methane, and water vapor. So those three things help trap sunlight and maintain Earth's temperature range. So all three of those things are big and kind of helping us keep our temperature the way it is. And the natural situation in which heat is retained in Earth's atmosphere by this layers of gas is called the greenhouse effect. So the fact that heat is trapped inside the Earth's surfaces by those three gases is called the greenhouse effect. Now people might say that global warming is occurring, which there's strong evidence that it could be, but there's no way to really know. And the reason global warming might be occurring is because we're having too much of these gases, too much CO2, too much methane, and it is trapping too much heat in, and therefore it is heating up our climate to above normal temperatures. And so again, the next one we're going to look at is how latitude will affect our climate. So that's the greenhouse effect. Now we're going to look at latitude. So solar radiation, so that's just energy from the sun, strikes different parts of the Earth's surface at an angle that varies throughout the year. So the Earth is on a tilt, so the sun is going to hit it at different times of the year. And at the equator, energy from the sun strikes the Earth almost directly. So if you know, the equator is like the center line around the Earth, and so at that point in time, the sun, or that point on the Earth, the sun strikes it almost directly. And then at the north and south poles, which are the very tip, the sun's rays will strike the Earth's surface at a lower angle, and therefore the temperature is not nearly as warm. And because of this different latitude, we have three different climate zones, and these climate zones, again, are affected by differences in latitude and angle of heating, and they include polar, temperate, and tropical. So all of those are going to be different zones, and here's a pretty good picture to show us where these different climate zones lie. So we have polar and polar at our north and south poles, and then going down from there we have temperate and temperate again, and both the northern and southern hemispheres. And then we have right along the equator, right there in the very middle, right at the center of the Earth, the line there is tropical. So this is going to kind of focus maybe in a little bit on your geography classes as well, kind of help us out to understand what our different climate zones are. And so our polar zones, they are cold areas where the sun's rays strike Earth at a very low angle, so the sun has to go a long way before it hits them. And polar zones are located in areas around the north and south poles between 66.5 and 90 degrees north and south latitudes. So our temperate zones sit between the polar zones in the tropics, and this is what we would be here in Illinois. We're in a temperate zone, and they're more affected by the changing angle of the sun over the course of a year. So that's why it's unbearably hot in the summer and extremely cold in the winter, because the sun's angle, or we're tilted away from the sun and tilted towards the sun at different times of the year. And as a result, the climate in these zones range from hot to cold depending on the season, which is what I just said. And our next one is the tropical zone, or just simply the tropics, and that's near the equator between 23.5 north and 23.5 south. And they receive direct sunlight nearly year-round, making the climate almost always warm. So yeah, I went to Jamaica just this past summer, and the coldest it ever gets there is around 70 degrees, or 65 to 70 degrees. And they say they actually do wear sweaters when that happens. So tropical zones don't know how hard they actually, or how easy they actually have it. And so the last section here is going to be heat transferred in the biosphere. So it's going to be how exactly are these different temperatures transferred along our part of the earth where life can exist. So unequal heating of Earth's surface drives winds and ocean currents, which transport heat throughout the biosphere. So this unequal heating makes us winds and ocean currents, and therefore heat is moved along the biosphere. So warm air over the equator rises, while cooler air over the poles sink toward the ground, and the upward and downward movement of air creates air currents or winds that move heat throughout the atmosphere. And so here's kind of the different winds that will result from the different unequal heatings. And similar patterns of heating and cooling will occur in Earth's oceans. So cold water near the poles sinks, then flows parallel to the ocean bottom, and it will rise in warmer regions. And its water can also be moved by surface winds. And the movement of water creates ocean currents, which transports heat energy throughout the biosphere. And then surface ocean currents warm or cool the air above them, affecting the weather and climate of nearby land masses. So this constant heating and cooling, so if you know, heating or cold air sinks because it's more dense, hot air rises because it's less dense. Same thing happens with water, and that's going to give us kind of our patterns here that will help us kind of figure out how heat's transferred, and again why these things actually occur, just because of different temperatures variations, again cold sinking, warm rising. So that's it for section 1. Let me know if you have any questions.